Okay, so we talked at the top of the show, we were talking about the Internet of Things. And I said we're going to have an example of an Internet of Things. We've had these on the show before where you have a device, a test and measurement device. We've had DVMs, we've had optical alignment tools, we've had other tools where the control or the data collection for that tool is your, let's say, your smartphone or your tablet. So we're going to look at another one of these today, and this one happens to be from Mahr, and this is going to be a surface measurement device. In this case, we're looking at the MarSurf RD18. This is a surface measurement drive. Keep in mind, this is just the drive, and where you'll see how it is going to be controlled by a Motorola tablet. Now, in the past, when you want to control one of these, and still now, if you wanted to do a lot of data analysis on surface roughness, you would use the RD18 with one of the other Mahr surface measurement systems, which may include a computer, a monitor, some higher-end software that does a lot of analysis on the surface measurement data you're taking. And of course, those come with a higher price. If all you need to do is simple surface measurement, you need to just scan a surface, get your surface roughness parameters, maybe generate a report, and that's all you need to do, why pay for a whole system? And that was Mahr's thinking when they came up with an app, an Android app, to control this device, so you don't need the rest of the system. All you need is the RD18, and in this case we're going to use a Motorola tablet. So let's take a look at how this works. This is really pretty straightforward. If we go to the gauge cam down here, we can see we've got our get it in front of the camera here. This is our RD18. This is just a drive unit. You can see all it has on it is a big green button. I'm going to press that button. That's going to establish my Bluetooth connectivity. I'm just going to wait for a solid blue light there, which tells me that I've got my Bluetooth connection to my tablet. And there we go. I'm ready to go. I'm going to launch the Mahr 1 app. Let me orient this so you guys can see that. Hold on. Come on, spin around. Oh, I guess I had it upside down. There we go. This is the Mahr 1 app. I'm going to select that device, and my app will launch here in just 1 second. And that's it. I am actually ready to start taking measurements right now. All I have to do is, you see in the lower right corner, I've got a little play button. I press that, and now it's going to start taking the scan. As I'm talking here, it's taking the scan, and it's drawing me a little trace. Oops, move this down a little bit. It's drawing me a little trace in capturing my data across the screen. Now, in the lower left corner, you see a 5.6 there. That is the travel distance for the probe. I can select any travel distance I want there, up to the travel length of the skid on the RD18, which I believe is 17.5 millimeters. I have it selected for 5.6 just to keep the scan short here. Now, once the scan is done, you can see at the top, and I'll hold it a little closer to the camera here, you can see I get a trace that shows the surface profile of the scan that I just did. And also, down below, we can see, get it into the camera there, we can see the various surface parameters that we just measured. We measured RA, or calculated, I should say, RA, RQ, RZ, Rmax, and RT. That's all there is to it. That's how simple it is. Right out of the box, push the button, within a few seconds you're taking surface measurement data. Now, if I want to save this data, which I do, create a report, all I do is click my little save button down there. That data is stored as a report inside my tablet. Now, let's take a look at some of the settings. I'm going to go into my settings, straightforward Android interface. You're all probably familiar with that, if you have an Android. I have some options here. I can get this where you can see it. I can decide where I want to store my data on the device if I'm saving it. What units do I want to use, metric or inches? Let's take a look at this one. What I want to calculate, and I have my choice. I can select, RA, RQ, RZ, Rmax. I simply put a checkbox next to the ones I want to display. I have them all selected right now, but I didn't have to do that. I could have selected just one of them, and we'll go back to our other screen. And also, you can select what kind of file you want to save. So that's how easy it is. But there's another thing. Let's go back to our regular camera here, Daniel. The other thing that's really cool about this, one thing I'm seeing more and more in portable devices is where the calibration reference is stored within the device itself. Now, if you've used some older surface measurement devices, and comes time you need to calibrate them, you know what you do. You go to your tool crib, you take out your little plastic box that has your reference, your surface reference tabs in them, you bring them back to the tool, you put them down, you handle them very carefully because they're typically small, and you try not to damage them, scratch them, or anything like that. You take your calibration measurements, put them back in the case, put them back in the tool crib. That's all very nice and well, unless you lose those references or unless you scratch them, get something on them. Much better if the reference is stored inside. Let me show you something. I need to do a calibration on this. I rotate the probe 180 degrees, retract it back inside. I'm ready to do a calibration. Let's go back to the gauge cam here. I click calibrate on the bottom, and it comes up. First thing it asks me is to say, well, what kind of calibration am I doing? I have my choice of RA or RZ. I simply look on the bottom of the device, and it tells me, here we go, it tells me we're going to do an RZ measurement, and the reference is 9.46 microns. So I simply come back here, I select RZ, I type in 9.46. I tell me how many passes I want. I'm just going to say just one pass just to keep things going. And that's all there is to it. I hit go, and it is going to now do a scan of, it's going to do a scan of the device, and it's being done internally. If it was doing if we can come back to the main camera here, if it was doing a multiple passes, the software would prompt me each time to initiate the next pass until all three, let's say 3 passes were done. In this case, I only did 1 pass. Once the pass is done, if we come back to the gauge cam here, it shows me that I can accept my calibration, gives me my calibration corrections that were done. I OK it, and I'm good to go. I'm ready to start measuring. And also, if I want to look at my data, I can simply go into another app within my Android, let's say in some sort of office or business app in there. I can go out to that PDF file. I can bring the PDF file up for reference. I can read it. I can email it. So you have all the same options that you normally would have with any other app or any other document that is stored on your device. Now remember, I did this on a tablet. Could have done it on my Android smartphone just as well. So you're seeing more and more of this, and you're going to continue to see more of this, where industrial instrumentation is becoming part of the Internet of Things, where why pay for a user interface when you already have a computer in your pocket capable of being a user interface? Why not use your phone or your tablet and pay, rather than pay more money to get a system that perhaps you don't need for your particular function? And again, that was the market for Mahr's product here. So again, great little product from Mahr. This is the RD18 surface measurement drive, along with the the MarSurf 1 Android app. Great little tools from Mahr. And by the way, the RD18 is just one of a series of surface measurement tools that that Mahr sells. They have a whole variety of surface measurement from kind of a handheld like this to higher up instrumentation. So thanks to Mahr for sending that to us.